Divisibility rules. Welcome to Mark's Math Methods. Divisibility rules. These are quick ways to tell if a number is divisible by another number, i.e. with no remainder. There are two types: by inspection, I'm just going to look at the number, and two, some easy work. These are meant to be quick, they're not meant to be time-consuming. Here are the divisors that we will cover in this presentation. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 2, 5, and 10 are by what I call inspection. 3 and 9, we sum up the digits, add the digits. 6 is a two-part test. 4 has a special rule. 8 is a similar rule to 4. And 7 is a clever rule, my favorite. And 1, seriously, you have to ask, every number is divisible by 1. Let's start with this side. So we're going to start with the inspection side. By inspection, divisibility by 2, 5, and 10. So we're just going to look at the ones digit and say, what do you see? If you see a 0, 2, 4, 6, or 8, that means the number is even, which means the number is divisible by 2. If you see a 0 or a 5 in the ones digit place, then the number is divisible by 5. Think about it, 5, 10, 15, 20, they all either end in 5 or 0. And if you see a 0 in the one spot, then we know the number is divisible by 10. 10, 20, 30, 40, 50, they're all divisible by 10. So by inspection is quick. So that applies to 2, 5, and 10. Now let's look at the 3 and 9, because we're going to sum up the digits. So if the sum you get when you add them up is a number that is divisible by 3 or 9, then the original number is divisible by 3 or 9. So let's take a look at 312. If I add 3 plus 1 plus 2, that's 6. 6 is divisible by 3. So that means that 312 is divisible by 3. 486, 4 plus 8 plus 6 is 18. 18 is divisible by 3 and 9, which means 486 is divisible by 3 and 9. 539. 5 plus 3 plus 9 is 17. 17 is not divisible by 3 or 9. 7,528. 7 plus 5 plus 2 plus 8 equals 22. Well, 22 is not divisible by 3 or 9. So that means that 7,528 is not divisible by 3 or 9. So for 3 and 9, we're just going to add up the digits. If the number you get when you add them up is divisible by 3, then the original number was divisible by 3. If when you add them up you get a number that's divisible by 9, that means the original number was divisible by 9. You're going to find that every number divisible by 9 is also divisible by 3. Divisibility by 6. This is a two-part test. Part 1, pass the divisibility test for 2, and that's an inspection test. Part 2, pass the divisibility test for 3. Well, that's a summing your digits test. So here's an example, 324. If I do the 2 test first, divisibility by 2, I'm just going to look at that position, the ones position. Hey, that number is divisible by, that's a 0, 2, 4, 6, or 8, or 0. So 2, 4, 6, 8, 0. So it passes the 2 test. If I add up the digits, I get 9. That's divisible by 3. Therefore, 324 is divisible by 6 because it passes both tests, the 2 test and the 3 test. 963. So I'll test the 2 test. It doesn't pass. So don't even bother doing the 3 test. There's no point because we're testing for 6. It must pass both tests. So if it doesn't pass the 2 test, it doesn't matter whether it passes the 3 test or not. Hint, this one would have. But it means it's not divisible by 6 because it failed one of the 2 tests, or both. 328. Well, if I look at the 1's digit, hey, it works. Passes the 2 test. Add up the digits, I get 13. That failed the 3 test. Therefore, the number itself failed the 6 test. It must pass both the 2 and the 3. The first one you want to do is the inspection one, because that's done quickly. If it fails the 2 test, there's no point to do the 3 test. Testing for divisibility by 4. This is a special rule. If the 2 digits on the right, the ones in the tens, are divisible by 4, then the original number is divisible by 4. Well, think about it. We know 100 is divisible by 4. That's 24. 25 times 4. So you don't have to worry about anything from 100 on because they're all divisible by 4. It's those last 2 digits. So we look at 312. If I only look at the 12, hey, 12 is divisible by 4. So then the original number, 312, is divisible by 4. 486. So I'm going to look at the 86. 86 is not divisible by 4. So the original number is not divisible by 4. If you're having difficulty looking at 2 digits and find out if it's divisible by 4, divide it by 2 twice. So half of 86 is 43. It's not even. I can't do it again. 539. So I look at the 39. 39 is not divisible by 4. So 539 is not divisible by 4. 7,528. So I just look at the 28. 28 is divisible by 4. So that means 7,528 is divisible by 4. Divisibility by 8. Similar to 4, but not quite as easy. So we're going to look at the 3 digits on the right, the ones, the tens, and the hundreds. Okay, if they're divisible by 8, then the original number is divisible by 8. 3,616. So I'm only going to look at 616. 616 is divisible by 8. This is why this is not as easy, which means the original number is divisible by 8. I could divide that in half and get 308, and then check to see if it's divisible by 4. That's one way to do it. 4186, 4,186. Look at 186. 186 is not divisible by 8. So the original number is not divisible by 8. 5239, 5,239. I'm only going to look at the 239, not divisible by 8. So the original number is not. And example 4, 7528. So I'm only going to look at the 528. It is divisible by 8. So then the original number is divisible by 8. Divisibility by 7. A simple but unique test. Separate the 1's digit and subtract twice that digit from the remaining digits. If result is divisible by 7, then the original number is divisible by 7. What? Well, let's do an example. It's much easier when you see an example. So we're going to take 392. We're going to separate the 2 off, so we're only left with 39. And we're going to subtract twice that 2. That's 4. 39 minus 4 is 35. 35 is divisible by 7. Therefore, 392 is divisible by 7. So we take that far right digit, double it, subtract it, and then check to see what you got. Example 2, 523. So we lop off the 3, subtract 6. We get 46. 46 is not divisible by 7. So 523 is not divisible by 7. 3,864. So let's lop the 4 off, subtract 8. 307, I don't know. Still a big number. So let's repeat the process. Take the 8, lop it off, subtract 16. 21, 21 is divisible by 7. So the original number is divisible by 7. This one is a cascading rule. It works. You can keep going. The same thing for summing digits. I didn't mention it back then, but the same thing, you can keep working it down. Tests may be repeated as needed. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.